5. Since my last name was M, I was in the first group, and I chose that my Galute N is going to equal to 10, and I'm looking for the pairs of offsprings. So, for the first randomized one, I got this, and it was when 9 didn't want offspring out of my initial 10, and 1 wanted it. So, what we were supposed to calculate was basically the standard error, and the standard error is when we estimate the standard deviation of the sampling distribution using p-hat, and the p-hat or p-capped, we use it to estimate the standard deviation of the sample, and basically we use the p-cap as a estimate. It's not a real number, it's more of an estimate. It's an estimate of the true proportion of the actual p. Okay, so to begin, I did for the first one, the sample size is 10, and the proportion was 1 out of 10 wanted offspring. And my standard error was 0.095, and there is what's it called, an equation for it. And so what I did was I put 0.90 times 0.1 all over 10, and that is all under the bracket to get it's taken the square root of. And when I did that, I got 0.095, so that was my SE. So then next I'm going to talk about the success and failure rate. I don't know if I'm getting this right or not, but I said it didn't meet it because when I went and did 0.9 times 10, that got me 9, and when I did 0.1 times 10, that got me 1. So those numbers are below 10, so for me, I said that it passed the failure rate. I'm hoping somebody can tell me otherwise. Okay. And then, so for this is for the 95% confidence rate. And what you do to get these numbers, so there's actually also an equation, and you're going to use 1.96 to multiply that by your 0.095 by your SC. So 1.96 is kind of a standard given. It's kind of 2 standard deviations above, which we used to use 2, but I actually read in the book to use 1.96, so I used 1.96, and then I got 0.186. And what I did is I did 0.1, because I'm looking for the care who wants offspring. So I did 0.1 times 0.186, and I got, for my lower number is 0.086, which is 8.6%, and I did the same for my upper. I did 0.1 times 0.186, and I got right here, my upper. So this is saying I am 95% confident that the people who want offspring, the Galutes who want offsprings, is between 0.086 and 0.286. That means I am 95% confident. Okay, so I did the same for the next one. The next one, I did the exact same thing. I did all of it. This one is 3 out of 10 want it. And so the SC I got is 0.145. I also said that this did not pass the success failure rate. Again, can somebody please tell me if I'm doing this right or wrong? So then for my lower level, I did the exact same thing for my confidence level, and I am 95% confident that I am between the Galutes that want offspring are between 0.016 and 0.584, or 1.6% to 58.4%. I am 95% confidence. That's my confidence rate, so that is a pretty good confidence rate. And I basically did the same thing, the 1.96, and I timed it by 0.14, and I got that, and I basically did 0.3 plus that and 0.3 minus that, because you plus or minus. It's basically, the equation is 1.96 times your SE, and then it's 1.96 plus or minus times this, your SC. So basically I minused it to this and plussed it to this. That gives me my lower and my upper. And that's my 95% rate. I did the exact same for this. So this one was 2 out of 10. So my SC, I got 0.126. Again, I used the equation. And again, for my success and failure rate, I actually said that it failed just because the numbers were under 10. Now I'm wondering if I put, instead of 10 galutes, if I put 40, that's higher than 10, of course. So I'm assuming that would pass the success failure rate. Again, I might need somebody to comment and help me on that. But for this, I also did, so I'm 95% confident that the offspring that wants galutes, which is here, which is 2 out of 10, they're going to lie between 0.047 and 0.447. So here I made graphs for all of them. This is the first one. Like I said, I was 95% confident, if we go back up here, that it's going to lie, the wants galutes 0.086 and 0.286. So if we go back here, here's 0.086 and 0.286, all right here. And so I am 95% confident that in this random pick, the galutes, the one offspring, are all going to lie right here. And again, I did that for the next two. So I am 95% confident, if we go back up to this one, that they're going to lie between 0.016 and 0.584. And so 0.016 is here, and 0.584 is all the way up here. So for me, I should have added a few more standard deviations, but as you see, there are no negative numbers, so it's kind of hard to make it even, so I kind of cut off there. But I would shade in the graph right here because I'm 95% confident that this is the proportion that wants offspring. And I did the same for here, which is between 0.047, that's my lower, and my upper is 0.447. So here, and I'm 95% confident that the galutes that want offspring lie here. Okay, so that is all of my information. So another thing we were asked to do is discuss how the three confidence intervals are similar and how they differ. The three confidence intervals, I mean, they're similar in the fact that they are covering majority of the proportion of the graph that I have drawn, but they obviously all are going to differ since they are different numbers. You can see that the less the care for offspring are just going to have a smaller piece of their confidence level, and the one that cares for the most is going to have the bigger piece, and so forth. So if we were saying 9 out of 10 wanted offspring, that of course the 95% level is going to cover basically the whole portion of them on the graph. And if we were going to have 1 million galutes on the planet, and these are the 3 independent samples drawn at this population, the results aren't identical in the 3 samples because it is, remember, like we said, all drawn at random. We can't predict that it's all going to be the same. And, you know, I was kind of surprised how much it differed, because I was thinking, oh, if we just add one more who cares for offspring, it's just going to make that graph look a little bit bigger. But no, if you can actually look up here, this is just 1 and this is 3. So it's an immense difference. And even 2 is even bigger. It's weird how it happens. I mean, it's not weird. There's an explanation. Obviously, it's by the equation. But since these are drawn at random, we cannot predict. And these are like a predicted amount. So I am surprised at how different the results were, but also how similar the results were across the 3 samples, because you can see, like on the graph, it's pretty similar. I mean, it just all varies where it starts, the lower level, or the lower number, and the upper number of the 95% confidence level. But that is my discussion for Module 5. Again, I am asking for somebody to help explain the success failure rate even better. And please make any comments if I have done anything to change. Thank you.